Hello. Little study advice here. Several students have been asking me kind of what can I do to study more effectively for the quizzes. And so this is a combination of a bunch of ideas that I've told to some individuals. So, the best time to be studying is sort of all the time, not necessarily the couple of days before the quiz. But you can apply these ideas throughout the next unit as we go. As you're solving problems in class or for homework or, whenever you're practicing coding, pay attention to at least three things. You want to be noticing if there are single line syntax things you don't know how to do, and keep your own personalized reference sheet. So if you have to look something up or get something from a partner, just write down the one line. And the things I have in mind are things like if you don't remember the right syntax for declaring and initializing an array. So in the last quiz, a couple of people did something like this: double array equals new double, but then they didn't specify the size of the array in the brackets here. And these are like very easily fixable mistakes because you get notes to remind yourself what the syntax is. And your own personal syntax things are going to be different than any list that I give you, so you just got to pay attention to that as you're going. Some common ones though, like remember the for each syntax, remember the basic syntax of all the methods that we've been commonly using within the unit. So for this unit, there are two different forms of index of, there are two different forms of substring. Okay, so maybe that's enough for syntax. This is not most people's major problem. So I would say the second thing that's maybe going to be the most helpful is starting to pay attention to recipes or patterns that are frequently used. And what I mean by recipes or patterns, they are multi-line solutions, usually about 5-line solutions to a general kind of scenario or a general kind of problem that comes up a lot. So an example of a recipe from a previous unit is the pattern for finding the largest thing in a list. And that pattern can be applied, and it's the same pattern to find the smallest thing in a list. It would be the same pattern if you were looping over a list of integers or if you were looping over a list of strings and you wanted to find the string that had the longest length. So that's why I say they're recipes or patterns. It's because there are lots of minor variations on the same general structure. And so you want to start being sensitive to that and paying attention to that and trying to note down what are these patterns. So in this unit, in my mind, we've had kind of two major patterns. One pattern is given a string, use index of to find a particular character or sequence of characters within the string, and then use a substring to segment the string into pieces based on those key characters. So from the project, one example was the timestamp. If you're given a string in this format and you want to convert it into seconds, you got to figure out where the colons are, and you have to extract the two characters before the first colon, the two characters between the two colons, and all of the characters after the second colon. So use substring to get those out as their own separate pieces, convert them into integers using integer.parseInt or double.parseDouble. And then you can multiply them by the things you need to multiply them by. So that was an example. And we did a warm-up that wasn't exactly like this, but you can imagine one sort of like this. Given an email address that's guaranteed to contain a single @sign, use index of to find where the @sign is, use substring to get out what's before, and use substring to get out what's after. And so you can well imagine, I could make up tons of other problems that employ this or that require this same pattern. Another pattern we've used a lot is looping over the letters of a string one letter at a time. And this is really just a variation on our older patterns that use arrays and array lists. So you're very used to looping over every item in an array and testing it for something. So you might count how many values are the same or something. And so this is exactly like that, except instead of looping over individual array elements, we're looping over characters of the string. And so the reason it's a variation is because in the for loop, you can't say, so like a equals 0, a less than array.length, a plus plus. So if it's the array version, you can access an array element by saying array I. If this is a string, You don't say length anymore like that. Length is a method. And then the way that you get the character at index I is string.substring I plus 1. And it's going to return a string that's an individual letter. But other than that, the way that you think about problem solving with this pattern is exactly the same. You can consider a string to be just a list of individual characters, and so you can think about it as if it's an array. And so we've done a couple of different problems like this. You could count how many X's are in a string. You could count how many double letters there are. So like PP is an example of a double letter. They're two adjacent characters which are the same as each other. We had to use that pattern when we wanted to find the location of the last space in a string. The first space in a string, everybody used index of to find the index where the first space occurs. But probably the easiest way to find the index of the last string was to use a for loop, but instead of looping from 0 up to the end of the string, we start looping from the last index going backwards. And so that's another example of how each of these patterns has several variations. Whenever you have a for loop, don't just think about looping forwards, you could also loop backwards. You don't have to start at 0 and end at the end. You could start in the middle and end in the middle, somewhere further along. You don't have to add 1 to the index every time. You could get every other letter out of the string. So you could have the indices go 0, 2, 4, 6, or 1, 3, 5, 7. So those are all different patterns to keep in mind. And then remember, there are patterns from previous units. I mentioned the one for finding the largest or smallest thing in a list. We had that pattern for how you build up a string one step at a time by appending to the end of it inside a loop. We have that pattern of using a counter to count things. We have a pattern of looping over a list and testing each thing until you find something that you're looking for, or you fail to find something you're looking for. So these are all kind of generic recipes that get combined in different ways. So far we have one-line syntax things. We've got common patterns that solve problems. And then the last one to look out for is whenever you have a bug, don't just treat bugs in class as, oh, I mistyped something, or, bugs are an inevitable thing. I mean, they are an inevitable thing. But there are common types of bugs. And depending on what type of code, I guess I'm trying to say, certain methods and certain patterns are susceptible to particular types of bugs that you can explicitly check for if you know that they're common. So whenever you're looping over a list, especially if you're trying to access an index that's not your loop counter, so you're not trying to just access index I, you might access index I plus 1 or I plus 4, you should always check to see if you're going to go out of bounds, just because that happens so frequently. Whenever we are, let's look at my list here. So common bugs, going out of bounds. Whenever you're using substring, it's very, very easy to forget that you don't actually access that last index of the substring. So if you write little notes to yourself, like one-line notes to yourself, use substring, check this. Using, for loop to access indices in a list, check this thing. And over time, you can build up the mental habit of the things that you have to check, and so you can catch bugs before they actually happen if you know what kinds of bugs are common. Okay. Excuse me. So then, for the A-level kinds of quiz problems, for the most difficult kinds of quiz problems, you're going to be asked to put together the common patterns in different ways, and combine several together. And we've done a few examples of these, and so I just wanted to show you what they were. So one that we did in class was swapping the first word and last word in a string. So for example, if the input is hello there Milo, we would output Milo there hello. If it was hello there my Milo, then the output would be Milo there my hello. So we just swap the first word with the last word. So when you're solving things in tests, it's a good idea to have some strategy, and you can write it down in pseudocode if you want. My kind of strategy is get the first word, get the middle stuff, get the last word. if I can do those three things, so let's call first word the first word, middle stuff is middle stuff, last word is last word. These are terrible variable names, by the way. Then I could return last word plus middle stuff plus first word. And so that's like a lot of the times when I'm problem solving, I think about like what data would be useful to have that would make the problem easy. So I'm sort of chunking my problem into smaller problems. So I know that if I can do this, I've got my problem solved. And so now I'll think, do I know how to do each of these things? So getting the first word is pretty easy because we can use index of to find that index of the first space. So first space equals string index of space. If there are no spaces, that, well, let's pretend you didn't think about that. So whenever I'm accustomed, whenever I write a method, to ask, what if this command doesn't return the thing I'm expecting it to return? So I'm used to practicing thinking about what are called edge cases, which are inputs that are not the expected input. So right now, as I was trying to puzzle through how am I going to solve this problem at all, I was thinking about this, which is an expected kind of input. But what happens if I'm asked to swap just the letter P? You know, that's not the normal kind of input that I would expect to get, but your code should still handle it cleanly. And those are called edge cases. But I guess let's postpone until the end to think about the edge cases. So if I'm just thinking about this input, okay, it's going to give me the index of the first space, and then first word is going to be string.substring from 0 up to first space. And now I'm thinking, remember, I'm double checking the common bugs. I'm thinking, do I want first space or do I want first space plus 1? So I have this habit of knowing what bugs are common and checking for them. And I'm thinking, okay, the first word really is just the first word and I don't want to include the space there. So I think first space is an okay ending index. All right, so first part's done. I've got the first word. Middle stuff. Well, let's see. If I knew the index of the last space, I could get the middle stuff. Same thing for the last word. So I've got a new goal. It's to find the index of the last space. I can't think of an easy kind of 1 or 2 line solution for this, so I'm going to make a method to give me what I want so that the solution strategy of my original method is still clear. I'm not going to type 6 lines of code right now to give me the index of the last space. Instead, I'm going to do this. Int last space equals index of last space, and then I'm going to give it the string. And so we could write the method that does this right now, or we could just pretend that it's given us the right answer and write it at the end. So let's do that. Let's pretend it's given us the right answer. So if it's given us the right answer, I can get the last word by saying string.substring last space plus 1, and then I just want to go to the end of the string. Why did I do plus 1? Because I don't want the last word to include that space. I want to start after the place where I saw the space. Okay, so I got the first word, I got the last word, and now middle stuff is going to be string.substring starting at first space and ending at last space plus 1. And the reason I slowed down there is because I was thinking about this particular string. So I'm thinking, all right, I've got my first word, so the middle stuff has to include that first space. And my last word is Milo, so the middle stuff also should include that last space. And so I want to end at last space plus 1, which is the M, but I'm not going to actually get the M because we don't actually get the character at that last index. All right, so now that I've done all that, I'm pretty much done. So I can say return last word plus middle plus first word. And now and you can see the solution approach is still pretty clear here. And now all I have to do is make this index of last space method. And hopefully this is going to be easier to think about because I'm not thinking about all the rest of my solution here. All the rest of the solution I know is going to work if I can just solve this one smaller problem. So now I'm going to forget my old problem and I'm just going to focus on this new problem. So how can I find the index of the last space of a string? And this is the other pattern. So we've used the first pattern of this unit, which was using index of to find something and then getting a substring out relative to that index. The other pattern is looping over the letters one by one, only this time I'm going to loop over the letters one by one, starting at the end, going backwards until I find a space. So let's do this. So I'm going to have I start at the end of the string, which is string.length minus 1. I'm going to go down, and I'm going to keep going as long as I is larger than or equal to 0. And now I'll get a letter out by saying string.substring I plus 1. What's happening? String.substring. There we go. And now I'll say if letter equals space, then I'll return I. And return exits right away. And so, the first time I see space, I'll just exit right away. If I never see a space, I'll return -1 as a way of indicating that I have never seen a space. Okay, so I'm pretty much done now. The only thing I want to do at the very end, sometimes it's worthwhile to trace your code from the very beginning step by step with a particular example in mind, just to double check all the things in your own head to make sure it's going to work on an expected example. Let's also double check that it works for an unexpected example. So if I want to swap D, that should just return D. So what's going to happen with this input? String index of space should return -1 because there's no space. And now I'm going to get a substring from 0 to -1, which is going to be an error. So I'm going to head off that error right at the very beginning. I'll say if it's not true that string contains space, then I'll just return the string, the original string unswapped. You don't have to do it here. You might have thought you could do it here. If first space is -1, that must mean that we didn't actually find a space. So here you could return string. The only reason I don't like to do it here is because line 13 is in the middle of lines 12 and 14, which are about part of the solution for a different input. Line 13 is about the input where there are no spaces. Line 12 and 14 are part of the same idea for what do you do if there is a space. And I don't like the fact that I'm mixing that all together there. So that's why I prefer the solution I had a second ago, where I first check for the unexpected edge case at the very beginning, and then as soon as I'm sure that we have spaces, now I can go through and do the rest of it. Last class we did the warm-up, which was return a list where all of the duplicate values in the list have been removed, or it could be a new list that only contains one copy of each unique value from the original list. What if I asked you to return the nth word in a string? So for example, get nth, and the string is hello there, this is a string, but then I want to get the third word in the string, and so that would return first, second, third. So it would return the word this. Could you write code that did that? Could you write code that did that even if there are potentially lots of spaces between the words? This is a much harder version of the problem. Could you write a version of the code that would still return the word this correctly even when you don't know how many spaces there are between each of the words? So if you want to practice, you can go ahead and practice this. I'd probably practice it on paper, or you could practice it on the computer first and then on paper. But you want to practice thinking about using the major recipes or major strategies to come up with a solution approach first. Then as you're translating your solution approach into actual code, you want to be paying attention to the common bugs that happen when you're using those patterns or those methods. And then at the end, you want to double check that it works and think about edge cases. And I think that process over and over and over again is going to get you, to become a very good coder. I hope this was helpful. If you want, I'll record some sample videos of me problem solving those two problems if you want. But for the moment, good luck.